Hi there, welcome back to my channel. In this video, I'll take you through the limits of rational functions. So, with limits, we have to find the limit as s approaches 0 of this expression here. So, this is what I'm going to use to explain the limits of rational functions. So, in our previous lessons on rational functions, you learned that rational functions, these are functions represented as a over b, right? Where a is g of x, b is what? Maybe b of x, right? So the quotient of two functions, provided that b of x is not equal to 0, gives what we call a rational function, right? So when you say a limit is simply the behavior of a function, right? The behavior of a function as we approach a certain point, right? So behavior of a function as we approach a certain point. So you realize that whenever we approach a certain point, the function tends to assume a particular value, or it tends to approach a particular value. So that's what we call the limit of that function, meaning that approaching this function through 0, this function will never exceed this, or it will be approaching this particular number. That's the idea of limit. So now let's solve this problem. So for limit of rational numbers, what you do is you first have to test for your functional value. You say functional value, right? So the functional value of a limit is simply what? F of 0, right? Putting your limit point inside your function is what we call the functional value, right? So a functional value may be equal to what? The limit, provided that our function is what? Continuous over what? A domain. Take note. If our function is continuous over a domain, then whenever you find a functional value, you should get the same as what? The limit. Take note. But if it is not continuous, you have to take away any discontinuity so that you can find the limit, right? So now let's see. Let's get straight to this problem. So solution. I have this function square root of s squared plus 9 minus 3 all over s squared, right? So I'm finding limits as x approaches 0. So the first thing to do is to find your functional value. So my functional value f of 0 becomes what? Square root of 0 plus 9 minus 3 all over 0 squared. The presence of this 0 squared indicates what we call a discontinuity. Discontinuity, right? So our function does not continue, or there's a breakage once you reach the point of 0. For that reason, we can't find the limit, or using the functional value. The limit is not equal to what? L is not equal to the functional value of 0. So the next thing to do is to take away any form of discontinuity if it's possible. So a discontinuity is said to be what? Possibly removable, provided we can adjust our function so that we can take the discontinuity out. So let's see if we can do that here. So here, this is a set, right? This whole expression is a set. So we can take the conjugate and multiply to eliminate that. So I'll have square root of s squared plus 9 minus 3 all over s squared, then times square root of what? S squared plus 9 plus 3, the conjugate, right? All over square root of x squared plus 9 plus 3. You realize that this here, it doesn't make any difference, because whatever you do for numerator, I do for denominator. You are only trying to modify it, but this one is just 1, right? So let's go on with our simplification. So simplifying this here, it becomes difference of 2 squared. So I have square root of what? S squared plus 9 all squared minus what? 3 all squared, right? All over, I'll simply multiply s squared multiplied by square root of what? S squared plus 9 plus what? 3, right? So when I have something like this, what am I getting? So you realize that this side is going to give me square root of, so I'll just get s squared plus 9 minus what? 9, right? All over s squared multiplying square root of what? S squared plus 9 plus 3. So at this point, 9 will cancel 9 and I'll get s squared over s squared multiplying square root of what? S squared plus 9 plus 3, and this will cancel this. So I'll simply get my expression to be what? 1 over the expression square root of what? S squared plus 9 plus 3. So I'll just take my limit as s approaches 0 at this point. Now I've removed the discontinuity. When I put 0, I'll simply get 1 over the expression square root of what? 0 squared plus 9 plus 3 outside. So this gives me square root of what? 1 over square root of 9, which is what? 3 plus 3, giving me 1 out of 6. So the limit is equal to 1 out of 6. And we have taken out the discontinuity by this simplification. So one important thing I'll tell you is whenever you have a rational function with a set, try to rationalize it to eliminate the discontinuity if there is. Thank you for being with me in this video. Please subscribe, like and share.